We're looking at the cube project today, guys. So this is just one side of our inner cube that we made, this cube right here, that we made on Thursday. And so we're going to find the length of it. Now I'm going to tell you right now, you couldn't just get a ruler and measure it because the origami paper is really not 12 centimeters. So we have to actually go through and solve it by doing these. If we could not throw our cube right now, that would be great. Or, ever would be even better. Okay, so the side length of my paper is 12, right? Now, this is still 12, but I folded 12 in half. So this is how much right here on the side? 6, good. So we agree this is 6 and this is 6, correct? For figure number 3? Okay, so we also agree that this right here would have to be 6 as well, right? So that's a what kind of triangle? Isosceles right triangle, right? So this would be what? What would this length be right here? Hint, hint, it's why I gave you your homework. Beautiful. 6 square root 2 is right here. Okay. Both of these again are 6. This is 6 square root 2. Now I'm going to take this, I'm going to fold it in half. So this is half of 6 square root 2. What's half of 6 square root 2? Good. That's it. Because you are. Okay. Now we're going to take it a step further. And instead of saying that the area or the length of the origami paper was 12, we're going to call it X. We're going to do this in a general way, just in case, let's say I said, okay, I'm going to say the origami paper is only 3 millimeters long. Well, it's really hard to fold 3 millimeters, okay? So this would be able to do it without folding, okay? So I'm saying that this is X, and we could plug in like 3 millimeters or whatever for it. So if this is X and this is X, what's this length right here? Huh? X over 2 is correct. Right? It's half of X. So X times 1/2 is X over 2. You with me? Ms. Murphy speaking. He's not here. Yep, bye. Okay. So if this is X over 2 and this is X over 2, what would this length be? X square root 2 over 2, we can just reduce it to, but X over 2 square root 2 is the same thing. Yep. But I'm just making it a little bit shorter. Okay, we still agree that this is X over 2, this is X over 2, this is X over 2, but this is X root 2 over 2. Okay, now I'm going to take X root 2 over 2 and fold it in half. What am I going to get? X root 2 over 4, perfect. Because you just times it by 1/2, right? I'm not going to sign that right now. X over 2 times 1/2 just gives us X root 2 over 4. Okay, we're going to double check if that works. What if I'm going to stick in, let's say 12, what's 12 divided by 4? 3 root 2 is our answer, right? So we know that this formula works. So no matter how many centimeters I've given, I can stick those centimeters into my original length of my origami paper in for X, and I will get the correct answer. Yes? It's centimeters. I did say 3 millimeters, so we'd have to figure out 3 millimeters is what fraction of a centimeter, and then we could plug that in to find the answer. Okay. Turn your paper over. Anybody have a question about this before we go? Because you're going to really need this for your homework for today. X divided by 2, because it's half as big, right? This was 12. This is 6, right? Because it's half as big. So this is X divided by 2. It's half as big. Does that make sense? Okay. All right, let's turn it over. We're going to do the big cube now. We're doing the big cube. Okay? We're just finding one length of the side for the big cube. So this is 12. So if this is 12, what's this side right here? 6. Good. What's this little part right here? This is 6, so this would be 3. So what would this slanted part right here be? Beautiful. Okay, so that's 3 square root 2, and there are 2 of those right here. So this would be what? Good, 6 square root 2. So that's the same length right here, from here to here. That's 6 square root 2. Okay, so when we fold this, this is kind of hard to see, but this whole length is right here on the bottom. So this is 6 square root 2. Okay? What would this part be on the top? It would just be this half. So this part on the top would be 3 square root 2, right? It's half as big. So this length right here is 6 square root 2. That's this bottom part. That's the important part because we're going to have to find the area. I will move it up. Yep, sorry. How are we doing? You kind of get how I'm doing this all by like splitting things in half or using 45, 45, 90 triangles? Okay. So now we're going to do this with x. Here's x. Here's x. What's this length right here? X over 2, right? It's half as big. Okay, this gets a little harder. You ready? What's this part right here? X over 4. Perfect. Okay, now what's this slanted part right here? Perfect. Good. All right, now I need to double that. So what goes here? X square root 2 over 2, because it's double. Remember, fractions like 1/4 is smaller than 1/2, right? So we don't want to do 1/8 because that's smaller. We want it to be twice as big. Okay, so again, right here, this is x square root 2 over 2. This right here is x square root 2 over 4, the top, but the bottom is x square root 2 over 2. Remember, I'm just taking this and putting it here because that's still the bottom. This right here is just half as big. But the important part, x square root 2 over 2, that part right there. Did I lose anybody? And if so, where did I lose you? This top part right here? Okay. Do we get that this side right here is the same as this half right here? And this right here is the same as this, x square root 2 over 2? So I just wanted to cut that in half. So I got x square root 2 over 4. Yeah. Okay. Ready? Now I'm going to pass out to you guys your homework. And I'm going to start off with giving you just a few hints for this. Okay? So this is all finding the volume. You're going to find the surface area first of your small cube and your large cube. Yep. And then we're going to find the volume of your small cube and large cube. And we're going to figure out kind of the ratios for it. So if we're talking about volume, how many of these cubes do you think fits inside your big cube? 4. You think only 4? Yeah, those things. All right. Yeah, you can do this. Yes, exactly.
Go grab one too.
Okay. All right. So right here, do you guys get
The big one.
Do you guys get that this? Do you guys get that this is the front face of the big cube right here? This is the front face of the big cube? Okay. I want to know, when we're finding area, it's what? What is the formula for area again?
Length.
Okay. Length times width. Length times width times height is volume. So just do area. So I need to know these two things, and it's a square, so I only need to know one of them, of this cube. So if I have, excuse me guys, if I have a 12 centimeter paper, and it's all folded, what's the length of each of these? So look at your paper. that we just filled out. Do you see at like the very last picture for the first half? What's the length of one side? Do you guys see this right here? That right there? That's one of these lengths, right? So what is it? 6 root 2. Okay. So you guys, I want to be clear that you're going to have to find the area of both. So you're going to have to do like 6 root 2 times 6 root 2, right? That's going to be the surface area. And then I want you to do it with the x. Okay? Then number 2, how many faces does this cube have? How many full sides?
8 or 6.
6. Okay, so you're going to take whatever your answer is and times it by 6, right? You're going to do it for the number version and with x. All right? Now let's look at the small cube. So we've got, the small cube. It looks like, this. Okay? What are the lengths of the size of the small cube? Turn your paper over, look at the front. What does it say?
3 over 2.
3 square root 2, yeah. Okay, so we know we're going to go 3 square root 2 times 3 square root 2, correct? Then you're going to do the x version. Okay, then it's also asking you for the total surface area of the cube, so you're going to take that answer and times it by?
2.
How many faces does it have? 6. The x version and the numbers. Okay, we good? Okay, let's turn it over. Now you're going to have the surface area. So you're going to take the big cube over the little cube. So you're going to take the answer for number 2 over the answer to number 4. And you're just finding a ratio. So what do you guys think it's going to be? No, this is just surface area. So it's like how many of these little squares and makes up this big
8.
square?
8.
No, not how many of the cubes fit inside.
Oh, 4.
8.
4.
There's,
24.
let me have them. Look. I need another one. I can't fit more than this many on here, right? So I cannot fit 8 on top, just covering, because it's just surface area. Okay? All right. So now, next we're going to do volume, right? Volume is what? Length times width times. And those are all going to be the same, right? Because it's a cube. Ms. Murphy speaking. Yeah, I can send it down. Just 1 second. In the East Main, no problem. Okay, so then we want to figure out the volume of the little one and the big one. I need your actual number, and then I need it with x. So you should have 4 things here. This is for your little. This is for your big. Okay. Then you're going to have this one. You're going to have the volume of the big one over the little one. Okay, so if we're talking volume, what should that answer be? How many little cubes can you fit inside the big one? How many? 8. Okay.
Can you go back up?
Yep, I will in just 1 second. 8 is a little bit harder. If you connect the midpoints of the 4 edges of one face of the big cube, what is the figure that you'll end up with? Y. And what is the area of that figure, including the empty space? I'm going to leave this one as like your challenge question. I'm not going to explain it, because I can't explain it without giving away the answer.
Please do it.
But I will go over it tomorrow. So try it. If you can't come up with an answer, it's okay. Try it. I can't without giving away the answer.
Oh, well.
Okay. All right. So that's it.